So process department to electrical provides the equipment drive requirements or a equipment list or a load list. This electrical load data of all mechanical equipments, which includes the nameplate rating, duty, emergency or critical power requirement, operation requirements. So this is required in order to build or prepare the load list, cable sizing, equipment sizing, and further other important internal working which will be utilized for further course of engineering design for the project. Then process also provides the control philosophy, which is sometimes mapped in the PNID document, the local control station requirement, remote stops, any interlock list, DCS interfaces, signal list, remote stop, and electrical heat tracing requirements. So these are all part of this PNID document, wherein this controlling philosophy, heat tracing requirements are mentioned in the PNID documents. For mechanical to electrical, checking the suitability of driver motor for a pump, top speed curve, motor datasheets. So these details are provided by mechanical to electrical. Gas turbine generator, steam turbine generator, reactive capability curve, generator datasheets. Hazardous area classification, hazardous area classification schedule, cathodic protection requirement, static earthing and equipment earthing, tank vessel tower dimensions for lighting protections. So these are the inputs usually provided by mechanical. In many cases, this hazardous area classification or HAC source list is provided by process team to electrical team for their equipment selection. For electrical to mechanical, we provide the vendor drawing review as part of vendor drawing distribution matrix document for mechanical packages like gas and steam turbine generator, emergency diesel generator set, pump skid, blowers, compressors, fan, pedestal cranes, electric hoists, etc. For vendor drawing review of process module like sulfur recovery unit, electrochlorination packages and other packages. From piping to electrical, we get the plot plan and unit elevation details. We get the battery limits, the ISPL, OSBL markings for any plant from mechanical piping team. Heat tracing requirements details, that is the line list and all those detailed isometric drawings. Cable tray routing, underground piping plan and piping plan in piping rack is a must to do this. So with respect to cable tray routing, the selection of pipe rack, the tire arrangements, all these things in the plant are freezed in discussion and alignment with the piping team. And definitely clash checking, hard and soft clash checking over the PDMS modeling. On and often we have to walk through the 3D model in the navies and look out for any clashes or any issues whenever the modeling is happening, so as to amicably align with respect to the space for the 3D modeling of electrical and piping discipline. For civil and structural team to electrical, the building design, substation design, floor penetration for panel installation, cutout for bus ducts, sleeves for outgoing cables from substations. So all these details, right, RCC, earthing, etc., all these details part of building design, we have to give a clear-cut instruction to civil. For substation, for the floor cutouts, for the cutouts for bus duct, right, supports, all this structural input should go to civil and structural to electrical. For the switchyard design, the structure design is done by civil. So civil has to provide us the input so as to enable the switchyard design for the outdoor electrical equipment. Transformer bay location and foundation design. Equipment loading. Plant lighting design. Underground facilities, underground raceway, trenches, duct bank, earth pit, etc. Earthing facilities, that is embedded conduit in the floor, embedded earth bars. All these details has to be provided by civil to the electrical team. Then support to prepare soil investigation report. So ideally civil team hires consultant for soil survey. So in that soil survey, we have to provide input to civil team that by Wenner's 4-pin method, we have to receive the soil resistivity data in order to proceed for the earthing design. So that data is also provided by civil team. The complete soil study report, wherein this resistivity information done through Wenner 4-pin is also mentioned, and that is taken as input for the earthing design. For control and instrumentation to electrical, so basically instrument load requirements includes MOV, motor operated valves, emergency power requirement and UPS, the control interfaces and schedule, motor, heater, electrical heat tracing, DCS IRP interfacing, ESD requirement for motor generators, and communication link between MCC and IRP, interposing relay panel or DCS. All this point has received from CNI team to electrical team. For telecom discipline interface with electrical, so the telecom load requirements has to be specified by the telecom discipline with electrical so as to consider the load in the load list for the transformer and load distribution scheme finalization. Then we have to understand the cable routing data or preferences for the telecom load. Then electrical to instrumentation and CNI and telecom team. So earthing requirements has to be mutually aligned with the E&I team, and accordingly the earthing design has to be considered by electrical team in the earthing design. Hazardous area classification layout for selection of instrument and telecom item. So basically in many cases our process team finalizes the hazardous area classification layout, which is taken as an input by electrical and instrument team for selection of fail-proof equipment for the plant. For HVAC, the panel heat dissipation data. So the heat dissipation data has to be provided for heat load calculation. The electrical power requirement for HVAC load, redundant power requirement or single load requirement has to be provided. So that has to be mutually aligned and agreed with the HVAC discipline in the start of the project. Control interfaces. So is there any specific controlling required for the heating, ventilation and air conditioning system? So those details and data has to be taken from the HVAC team. And finally in the equipment selection, that is dedicated HVAC MCC is required or not, the motor design, the blower design, exhaust fan requirement to control the ACWH, air changes per hour, the power and control cables and the control system design can be only done if the HVAC discipline inputs are provided on the right time to the electrical department. So here is a small table to understand in a nutshell the interfaces that we had discussed as of now. So electrical discipline with the project team as we see here. So project data is the flow of interface and the electrical deliverables. So project site data or process data and the grid and utility requirements, once we have these data, we can start the initiation of preparation of electrical design basis document, the fundamental basic document for any electrical design of a project. Through these details, we can start the preparation of single line diagram once we have the load list, data and grouping of MCC and loads. And after the equipment list is sized, maybe we can start the initiation on preparation of electrical load list. For project deliverables, once the document control index, so it is a reverse flow as you can see here. So electrical deliverables or DCI and subsequent updating of electrical project control documents. So once this electrical DCI and the subsequent documents are updated, so this will go as an input to the project team for the preparation of firstly the overall document control index document DCI, wherein these electrical documents will be mapped. The work share plan, if the project is happening through a work share, the project manager with the engineering manager will prepare a work share plan, detailed work share plan, to as how this work sharing will happen between the field office and the satellite offices. Then the weekly progress reports can be generated successively. And for the project services, it's a multiple way communication as you can see. So coordination between other disciplines, clients, vendor, third party for any statutory or any leasing agencies. So deliverables, meetings, email correspondences, vendor engineering review test inspections, vendor inspections, FAT, SAT can be done for the electrical services point of view. So this is a bidirectional data as you can see, the deliverable meeting email correspondence. This can also go through the project team for the coordination